Hello everyone, welcome to Pepcoding. In today's video, we'll look at the question construct target array with multiple sums. Okay, so let's see. In this question, let's say I have the example of 935. Okay, I've given an array of 935, right? And I have to, let's see, I have an array of 1, 1, and 1. So I have to make this array using this array of ones. Okay, I have to make this 935 using this array of ones by performing some operations. Okay, and the operations are, let's see, I have 111, right? I will find the sum of all three numbers and I will get 3, right? 1 plus 1 plus 1 is 3. So my sum is 3. I will replace one element here, one element with this 3. So I will get 1, 3 and 1. Okay, now I will I'll do the same thing. I'll find the sum of these three numbers and this will be 5 this time, right? So I'll replace one number with this 5. So I will get 1, 3 and 5. Okay, now I'll do the same thing. I'll find the sum. It will be 9, right? 5 plus 3, 8 plus 1, 9. So I'll replace it with 9, 3 and 5. Right. So I got this answer 935 by using a couple of ones, and I performed the operation of finding the sum every time and replacing it with one of the elements. Okay. So if I get this answer, then I have to, if I get this answer or my desired array, I will return true. Okay, else I'll return false. So let's see. I hope you understand the question. Now let's take another example of 1, 1, 1, 1, 1 and 1. Right. Now let's find the sum. It will be 5. So I will do 1, 5, 1, 1, 1. Okay. Let's take another sum. It will be 5, 6, 7, 8 and 9. Right. Replace one element. 1, 5, 9, 1, 1. Okay. Let's find the sum again. It's 17. So I'll replace 1, 5, 9, 17 and 1. Okay. Let's say this was my desired array. Let's say my array was 1, 5, 9, 17 and 1 only. And I got this array using this ones. But is this an optimized approach? Right? I have to make an array every time. And I don't really know when to make the changes. So first I have to find when to make the changes, where to make the changes, and then I have to replace every number with the sum, right? So this is not an optimized approach to go this way. But what if I take this array only? And by doing some constant time work, or O of 1, let's say constant time, in some constant time, I'm doing this work in the reverse manner. And if I get this array, this 1, 1, 1, 1, 1 array, then I can say that this array is my valid answer, right? So I can return true for this answer. If by performing some reverse operations, I can get this array. Okay. So let's see. Let's say this is my array. Now, what is the maximum element in this array? Right? The maximum element is 17. The maximum element is 17 here, right? And this 17 element, isn't this 17 element the same element of the sum of this array, right? So the maximum element will be sum of previous array, right? Or previous elements. So I can say that my current sum, which is or the current maximum 17, is the sum of the previous elements, right? This is same as the previous elements, or the sum of the previous elements. Now the relation here, right? I can find this relation. I can see that the relation here is that this 17 is the sum of all the previous elements, right? But have the previous elements changed except this 17? No, right? The previous elements haven't changed. Except this 17. So this array and this array, the rest of the array except this 17, here and here are the same thing, right? Only this position has changed. right? Only this position has changed, but the rest of the array is same, right? So what I can do is, if I somehow find the rest of the sum, if I somehow find the rest of the sum, then can I get this array, or can I get this number, this the element which has changed? Okay, let's find out. Let's say that this sum, the maximum here is 17, right? And the sum here is 1, 17, 18, 19, 20, right? So, okay, so it's 33. So my sum here is 33, and if the sum here is 33 and I subtract this number, this 17 from here, then I will get my left sum. Or what I'm saying is that if I subtract this sum, if I subtract this maximum from my sum, then I will get the sum of these elements, right? The total sum is 1 plus 5 plus 9 plus 17 plus 1, right? That is my total sum. If I subtract 17 from this, I will get the sum of these elements, right? Or the left sum, the elements of the left elements, right? All of the elements which are left. So this left sum will be same as the sum of these elements, right? So I can say that my sum here was 33, right? I can say that my left sum will be that if I subtract my maximum from my total sum, then I will get my left sum, right? Which is the sum of 159 and this one, right? Now I just need to get this one, or I need to get the element which was changed. So how can I get this element, right? First see that the changed element, right, or the changed value here, this changed value, I can say this changed value will be same as if I subtract my if I subtract my left sum from my maximum. So if I have this maximum and if I subtract my left sum, right, what will I get? The total sum here is 1 plus 5 plus or the, let's say, the previous sum. Let's call this the previous sum, right? Let's say my previous sum here is 70. This total sum is 70, and this is same as my max, right? So I can say the previous sum is same as my maximum, right? This is true. Now if I subtract the left sum, this left sum here, if I subtract this left sum from this maximum, then I should get this element, right? Because this rest of the left sum is same in both the arrays, right? This 159 and 1 is same as 159 and 1 here. The only element which has changed is this. So if I need to find this element, then I can subtract my left sum from my maximum, right? The left sum from my maximum, so I can get this element, right? So if I subtract this left sum from my maximum, then I can get this element, and that is what I need. Okay, so this is my approach. And also I need to find the maximum element in every in these arrays, right? So I need to maintain the maximum element in some sort of way that I can get it in optimized manner, right? So I will use a max priority queue. Okay, so I have this. Now let's talk about some edge cases, right? If my sum, or if my left sum is less than equals to 0, right? What happens if my left sum is less than equals to 0? It means that if it merged with my total sum, if my left sum was less than equals to 0, then it means that the elements which merged with my this element gave me a maximum, right? But if the left sum was less than 0, then the maximum would have been smaller. Okay, so if the maximum was smaller, it means that these elements were negative, right? And if these elements are negative, then I will return false, because that is not true. Okay, for that case, for if my elements are negative, then I will return false. Okay, I can have also the case where my left sum is greater than equal to my maximum. Okay, then also I'll return false. And why is that? Let's take this array of 1, 1 and 1. Okay, I have this array, and if I perform the same thing, I will have I will have the sum as 3, then I'll replace one of them. Okay, now my sum here is 3, right? This is the maximum element here. But I'm saying that my left sum is greater than my maximum. It means that the sum of these values, right? The sum of these values are greater than my maximum. Is this really possible? If this value was greater than this 3, this maximum, then it means that this element would have been negative, right? If I have this -1 here, and if I take the sum now, it will be 1, right? But I haven't let's say that the sum here is 3 only, right? So if I replace this now, that my left sum is 2, right? And here it is 1, right? 1, 1 and 1. So it means that this 2, this left sum, when added with this -1, gave me a 1, right? So it means that if the left sum is true, then if the left sum is greater than my maximum, then this is my maximum, right? If the left sum is greater than my maximum, then this simply means that this element was negative. And for that case also, I'm going to return false. So I've written the case that if my left sum is greater than or equal to maximum, then I'll return false. Okay, so this is my approach. Now let's try to code this. Okay, so first I will take sum as long. Now we need a max priority queue, and since the priority queue in Java is of min type, then we need collections dot reverse order, right? Reverse. Okay, now for int element target, I have to fill this priority queue. So pq dot add. Now I have to convert the element also. So long typecast element, right? So long element. Now sum plus equals to element. So I'm also updating the sum as we put the elements in the priority queue. While pq dot peak is not equals to 1, right? If pq dot peak is equals to 1, then it means that all of the elements are 1 only, right? So long top, at that moment I'll stop and I'll return true. Okay, so while long top is equals to pq dot poll, I'm getting the maximum element. Now I'll subtract this top from my sum, right? If I subtract this, I will get the left sum. So this is my left sum only, but let's update the sum only, right? Now if this sum is less than equals to 0, or if this sum is greater than equals to my top, if this is true, then I'll return false for that case, right? And now if my top will become top minus sum, and my sum will be sum plus equals to top. Also, I'll add this only when my top is greater than equal to 0 or greater than 0. If my top is greater than 0, then I'll add my top, else I'll add my sum. Okay, if this runs fine, then it means if this while loop terminates, then it means that that my value or my array is valid, so I'll return true for that case. Okay, but here we have a problem. Okay, the problem of this statement, top equals to top minus sum. What is the problem? Let's say I have 1 comma 1 comma 1, right? And I take the sum and I get 1 comma 3 comma 1. Again I take the sum, I'll get 5 1 comma 5 comma 1. I'm only replacing these values. Okay, next I'll get 5 6 7, right? So 1 comma 7 comma 1. Next I'll get 9 1 comma 9 comma 1. Next I'll get 11 1 comma 11 comma 1. Let's say this was my array, right? But if I reverse this, I'll have to do this many number of times, right? But this is only changing for one position, right? So I can do a jump here. If I do top equals to top modulo sum. Instead of subtracting the sum, I can just do modulo. Okay, so here instead of subtracting the sum, I'll do a modulo. Okay, this looks fine. Now let's run this code. It is successful. Okay, let's submit this. Okay, it has passed all the test cases. So I hope you understand this question. If you don't, I would suggest rewatch the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.